Unit 3, Formula 2, Day 3. These are the application problems, which means the word problems. So do not just do the first problem and stop. Write every single problem down. More than likely, I would like you to write it word for word, so that way you know what you're doing, because I'm not going to be there tomorrow to help you guys through this. So I will be there Monday to answer any questions before the test, but you need to be able to write this down and be able to look at your notes and use it to answer these questions. Number 1, you go to the store to buy candy bars and pop. You have no more than $10 to spend. Candy bars cost $1 and pop costs $2. Write the linear inequality that models the situation. So first of all, we have two different things. We have pop and candy bars, which is good because in our equations we have an x and we have a y. Okay, so x can be our candy, y can be our pop. Okay, we actually have done some equations like this. Okay, if candy costs $1, that's 1x plus pop costs $2, so 2y. So 1x plus 2y. Now you have no more than $10, which means you have to spend less than or equal to $10. Okay, now you're going to have to graph. Well, this is in standard form, so you set up your two equations. So 1x equals 10, 2y equals 10. So x equals 10 and y equals 5. Y equals 5 up here. X equals 10 over here. Look back at your symbol. It's a or equal to, so which means we need a solid line. Okay, sorry, it's kind of an ugly line. Now we got to figure out where to shade. Okay, you can spend no more than $10. So you got to look at this. You got to plug in 0, 0. Okay, so you have 0, 0. So 0 is less than or equal to 10, which is a true statement. So we got to shade towards 0, 0. So my answer for these word problems, now that they're an inequality, is a graph, because we can spend any of this. But now we got to think about this real quick. Can I buy negative candy bars or negative pop? No, so really all of our answers are right in here in this little triangle. And we'll talk about that a little bit more on Monday. Okay, so just make sure you have that problem written down, you know how to set it up. How do you know where to shade, and explain with an example of the graph? Okay, well, you know where to shade because it's either a greater than or equal, or a less than or equal sign. Okay, and that sign tells you where to shade. Now we use 0, 0. We plug it in. We figure out if it's a true or false statement. Okay, if it's true, we shade towards 0, 0. So we can even write that all out. Plug in 0, 0 to see true or false. Then either shade towards or away from 0, 0. Okay, that's how we figure it out. When do you use a solid line versus a dashed line? What do you know about the points on the dashed or solid line? Okay, well, you use a solid line when it's or equal to, meaning when it has that line underneath in the equation. Okay, you use a dashed line for the other ones. What do you know about the points on the dashed line? Well, on the dashed line, we know that it's dashed because it's not equal to, so the points on the dashed line are not answers. Okay, if you look at your day 1 notes, you should have that as well. The points on the dashed line are not answers, while the points on the solid line are answers. Okay, make sure you got all that written down. When can you not use 0, 0 to determine where to shade, and how would you choose a point? The only way you would not be able to use 0, 0 to determine where to shade is if it is a point on your line. If it's already a point, not life. Sorry. On your line. Okay? If it's a point on your line, you would have to pick a different point to shade. Okay, so, and you would just choose a point not on the line. Okay? Make sure you have all that written down. We will see you Monday.